Hey guys, welcome back to the fifth video. So now I'm going to show you some data. So I'm going to take a data set and just to show you how all the equipment works and what you are missing out on essentially. But you'll be here with me as I take it, so you'll feel like you're all part of the action, I hope. So this is, hopefully you've read through all this probability of measuring along 1 alpha, which is the left polarizer's angle, linear polarizer. So with the probability of detecting a alpha polarized photon, and we're assuming alpha and beta are just angles that are like a linear polarization at some arbitrary angle, and alpha represents the left one, beta represents the right one, okay? So hopefully you've looked at that and you've looked at, you've got to this question, which tells you to come up with an expression that relates the probability of, this coincidence detection between an alpha and a beta, 2 photon state, recording that, and the number of counts that we record on our control unit, which is this, okay? So this is the first detector, second detector counts, red and blue, and then coincidence here. And we can see that, as I turn this one of these polarizer angles, I'm just going to turn this clockwise, and look at the counts, they change based on how the 2 polarizers are related to each other, and they should change in a certain way, okay? So that's your n of alpha and beta function. Now when I take the data, I'm going to do a 10-second average, which I've already set. So if I press the user button, that's just the user settings, so I've set that to 10 seconds average. So this will, it's not actually an average, it's just an integration time, so it just adds them up over 10 seconds. That's why it's a bigger number, but that's what we're going to use. We're going to do a 10 seconds, try and average out the deviation in any given measurement we're going to take, right? So there's a question in there about what kind of distribution we imagine these incoming photons to be described by. So what is that? I'm not going to just give it away yet. But the idea is that, all of these number of photons coming in at any given time, and therefore integrated over however many seconds, is going to fluctuate. And it's going to have some deviation that are described in a certain way. So you'll need to do maybe a little bit of reading, research. You might already know. It's very common in quantum optics, very common distribution that describes a random variable, which the random variable in this case is the number of arriving photons from some source. Okay. So, task 3.1, 3.2, 3.3, I've chosen my angles. I've got my Excel spreadsheet. These are the angles I'm doing. Now you'll notice that in the lab manual, I said to set 4 for alpha and then vary beta. So like set the left one, vary the right one. It's arbitrary, and I've actually chosen to do it the opposite way for reasons I will not yet disclose, but note that there is a reason that I'm doing that. And you will probably, when you plot the data, you may kind of figure out why I did it that way. Anyway, we can talk about it later. So that's what I'm going to do. I've got my 4 beta angles and I've got 12 alpha angles spread over the 180. Why have I chosen them like I have? So you'll get this data set, and now I'm just going to record it. I'm just going to go through it, and I'm going to write down the 10-second averages for each pair of angles that I have. So let me mount on my trusty boss head and clamp my phone, and hopefully the claw on the clamp doesn't destroy my screen. I've got a plastic glove on it to like stop it from trying to cushion it, the clamping, but I also don't want it to be clamped too soft so it falls out and smashes on the desk. Alright, So I think you can see, I'm not entirely sure, because my glove is covering the screen. Anyway, so this is how we take some data. So let's do the first set of angles, alpha 0, beta 0. Now I should unscrew this and put it in a region where it's going to be more helpful for me, given the range of angles that I've selected. So over here. Alright, 0, 0. So that's my HH. I'm taking H to be 0. Alright, now I'll wait my 10 seconds. $12,602, 12,602. That's my first data point, right? So now I'm going to keep the same beta and I'm going to change alpha. Next alpha angle is 22.5. So they've got 10s marked, and then each one is 2, so it's sort of just after the first div there. Kind of hard to get, but I'll be within a degree. Alright, and then I'll wait for my averaging, or not averaging, integrating. One, 697. $7,516. So this is what doing a lab's really like. So if you think that this is boring, you have the coronavirus to thank for that. So say thank you to the coronavirus for saving you from what I'm about to spend the next however many, half an hour or so doing. 2551. So I'm just going down so I've got the beta 0, as you can see, and I'm varying alpha, okay? So you should be able to see, I'm changing this. That's what's happening. Next angle is 70, so it's actually a very slight difference. Probably too close, actually. Let's make it 75. Let's make it 75. Integrates. $1,566. Next angle is 90. Integrate. $290. 112.5 is the next angle. Just about there. Integrate. $2,095. Next angle is 135. Integrate. $7,103. Next angle is 145. integrate. $9,447. Next angle 157.5. Just before the last div there. Okay. Integrate. $12,022. 165 is the next angle. Integrate. This is why it's good to work in pairs, so you actually have somebody to talk to while you're just taking data and doing nothing. 13,202. Next angle, 180. Integrate. $13742. Done. Alright, so that's one set. So now I change beta to the next beta angle, which is 45. And I take all the alpha angles again, okay? And then I do that for 4 beta angles. And then what I'm going to do is I'm going to change the state. I'm going to go into here and turn the wave plate out. So I'll probably do a video of that after or something. But this is the end of this video. You know what I'm doing. Cool.